So we are going to go over this first semester final review, just giving you a little bit of a refresher over the things that we have gone over this semester. We're going to be graphing, looking at a lot of quadratics, and remember, whenever we talk about a quadratic, we're always talking about an equation with a degree with the highest exponent of 2. And we can have quadratics written in many different ways. We'll be looking at that. We're going to be solving quadratics. We're going to be graphing quadratics. We're going to be rewriting quadratics. But first, before we get to the quadratic, we're going to be looking at an absolute value. And we see here on this first problem that we have an absolute value function. And with that absolute value function, we have a set of bars, which represents that is an absolute value. So it asks to graph the following function and then state the vertex, understanding that an absolute value produces a v, easy to remember because value starts with v. And these v's do have a vertex. It's where the graph comes to a point and then changes direction into a different, goes in a different way. And so to find the vertex in an absolute value is fairly simple, because we take the opposite of what's inside the bar as our x value. So we would write that as -3, and then the y value is what is hanging on outside of the absolute value bars, and we take it at face value for exactly what it is. So inside the bars, we take the opposite. Outside, it stays the same. So that gives us our vertex at -3, -2. Now on this graph, I am going to have to draw in my x and y axis. Not a big deal. I'm doing it a little off because my vertex is -3, -2. So I go from the origin, I go to the left 3 for the negative on the x value, and then I go down 2 for the y to get my vertex. I know that this is going to be pointing up as this first v represents, because what's out in front of the absolute value bar is positive. There's no number, there's no negative out in front, so therefore I can assume that to be +1 that's out in front. Now for absolute values, since it's made up of 2 line segments, so to speak, and since they are lines, I can actually use slope in order to find my, to graph this. And every point going up to the right of the absolute of the graph will be reflected over onto the left-hand side as well. So here I know that that is a 1 that's out in front. I can make that an assumption because it's not there. So that means I'm going to rise up 1 and go over 1. So that's up 1, over 1, up 1, over 1, up 1, over 1. And I'm doing that to the right. Now, because it's absolute value, that means I have a perfect reflection over to the left-hand side. It's got symmetry to it, we call that. So I bring that over, and bring that one over, and bring that one over, and there I have my absolute value graph. I probably, if I wanted this to be perfectly straight, should have used a straight edge. And there's my graph for the first one for absolute value. And we see on the next one, I'm not going to work this, I'm going to allow you guys to work on that, but I have a negative out in front, which represents this is going to be a negative graph. Therefore, my slope will be down 1 over 1, down 1 over 1, down 1 over 1, just like we did here, but it was positive, so it was up 1 over 1. So for instance, if I have a slope that was out in front, let's just pretend I have this. So here I have a slope of 2/3. That would be, I'd be going up 2 over 3, up 2 over 3, up 2 over 3. And whenever we're looking at that, we always start at the origin and make our movement from the origin of the vertex, from the vertex. Not the origin, I apologize. It is from the vertex. I pointed to the right thing, I just didn't say it correctly. So from the vertex, I'm about ready to say it again. From the vertex is how we calculate our slope. Okay. All right. Second set of problems, it says to rewrite the quadratic in standard form. And we know that in quadratic we have 3 forms. Standard looks like ax squared plus bx plus c. That's standard. Intercept is a times x minus h quantity squared plus k. And Intercept is, we could put the a out in front, x minus p times x minus q. I can set all of those equal to 0. And again, we have standard, we have intercept, we have standard, we have vertex, and then we have intercept at the bottom. In standard form, this is just a quick little recap. In standard form, C is my y-intercept. That's something that we can pull out of that equation pretty simply. In vertex form, which is my second one here, it's very easy for me to pull out the vertex in vertex form, and that's what we did. Very similar to the absolute value that we did. We take the opposite of h, and then k gives us our vertex. And in intercept form, we can find our zeros by taking the opposite of p and the opposite of q, and that tells us where the graph crosses the x-axis. Okay, so looking at this section here, I see on A that I'm in vertex form. And so if I want to rewrite this into standard form, I'm going from equation number 2 here to equation number 1. And so that means I need to multiply out anything that I need to, that requires it to expand. So I see here that I have a square. I know that that square means that whatever is at the base, I'm going to multiply by that base that many times as what's written as the exponent. So that's a 2, so I'm going to take x plus 2 and multiply it by twice. X plus 2 times x plus 2 plus 18. So now I can either, and I know that we learned how to do the box, x and 2 in the box. I made this very sloppy. I'm not sure why I did that. That gives me x squared, 2x, 2x, and 4. So what I have now is x squared plus 4x plus 4 plus 18. Okay, so what I did is I multiplied those two binomials first using the box method, or lattice, however you want to word that. Now I have this -5 out in front. Now I can multiply that by distributing that -5 to everything. So I get -5x squared minus 20x minus 20 plus 18. Using, by combining any like terms, the -5x squared, I don't have any other x squares to add, so, and I don't have any other x's, so that stays put, but I can combine my -20 and my 18 into -2, and so that would be my final answer. So if you look at B, you would work that just the same as you would with A. And at C, I've got the two binomials being multiplied, and I can do that strictly by using the box method on both C and D on that. Okay, the last section on this front page asks us to find the zeros. I'm in factored form, so to find the zeros, I need to be in factored form. And we really haven't, on this sheet yet, done factoring, but fortunately for us, this is already in factored form. So once in factored form, I take each factor and set it equal to 0 to solve, because we're always looking for x. What is x? And 90% of the time, the easiest way to do that is to set the equation equal to 0 and solve it in the ways that we have learned. And so I'm going to take each one of these zeros and I'm going to set it, or excuse me, each one of these factors and set it equal to 0. So I get x equals -1 and x equals 2. And so there I know for this equation that once I'm in factored form, I can set each one of those equal to 0 and solve. I know that the graph, if I would graph that, would cross the x-axis at -2, or -1 and at 2. Okay, and I would do the exact same thing with B. Okay, flipping over to the next page. And I think this is a little bit out of order, so I'm going to come back to this page here in a second. It asks to find the vertex, so we're over here on number 4. We want to find the vertex of the following functions. So we've already found the vertex we know in vertex form it's the easiest. So I take the opposite of what's inside the parenthesis. So -1 becomes 1, and what's on the outside stays put. So the vertex is 1, 5. You would do the same thing with B. I'll let you work that on your own. Now I have intercept form. I don't have the vertex given, so I need to solve for the vertex. And so in intercept form, I'm taking the opposite of P plus the opposite of Q, and then I'm dividing it all by 2, and that's going to give me my x value of the vertex. And then once I find the x, to get the y value, I just plug in the x value into the original equation. Okay, so taking the opposite, so I get -1, and then -1, opposite of that is 1, divided by 2. -1 plus 1 is 0, divided by 2, so the x value here would be 0. So now I'm going to plug 0 back into the equation, and I'll solve for my y value. 0 plus 1 is 1. 0 minus 1 is -1. Now I take those two and multiply it together. 1 times -1 is -1. So my vertex is 0, -1. On E, now notice I've got vertex form, intercept form, and now I have standard form for the last two. And for standard form, it's the same thing as with intercept. I have to find x and then plug it back in to find my y. In standard form, to find my x, I take the opposite of b over 2 times a, and that's going to give me my x value of my vertex. And understanding in standard form, it's a x squared plus bx plus c. So if I'm looking for my b and my a, here's my b, so I take the opposite of b, so it'd be -3 all over 2 times a, which is 2. So -3 divided by 4. So -3/4 is my x value. So then I would take my -3/4, and you are welcome to use a calculator because you will have access to that. So I take 2 times -3/4 squared plus 3 times -3/4 minus 1. And so my x value I know to be -3/4. I'm looking for my y. So I'm going to grab my calculator, and I'm going to take 2, can you see me, times -3/4 squared plus 3 times -3/4 minus 1. And I get -2.125, which is actually 1/8. Or you can leave it as a decimal, that would be fine. So there is my vertex. Let's see, we could write it as -0.75 or -2.125 is a way to write it. We could write it as -3/4 and -17/8. Honestly, I would prefer this last one, but it all depends upon how the author of the test you're taking, how it's represented. So understanding that all three of those mean the same thing. Okay, let's look at factoring. Factoring is an important part. Any class that you're going into next year, you'll probably be doing some factoring, and what we're going to be doing here is factoring a trinomial. Trinomial means I have 3 terms, means I have 3 things being separated by a plus or minus. So x squared plus 2x minus 3. So 1, 2, 3 makes this a trinomial. When a is 1, we've got a super easy factoring. We set up our diamond. That's not a diamond. I guess you could call it a diamond. Our x. And we say 2 numbers that multiply to give me this last term, -3, but add to be the middle term, which is 2. So we want multiply here and add here. And so 2 numbers that multiply would be 3 and -1. 3 times -1 is -3. 3 plus -1 is a positive 2. Now, all because my leading coefficient here is 1, I can substitute these factors directly, or terms, however you look at it, directly into my parentheses. So I get x plus 3 from a 3 here and x minus 1 from this -1 here, and can go directly in when my leading coefficient is 1. Now let's say our leading coefficient is not 1. Look at C. Now I have to do a couple extra steps. Now I'm going to take A times C to get this value here. So 2 times 8 is 16. So instead of just saying 8, two numbers that multiply to 8 to give me a negative 10 won't work because I've got this 2 out in front. And so I need to then multiply the 2 times 8 and then what numbers that then add to give me negative 10. And I can see that to be negative 8 and negative 2. And I notice that I've got a negative in the middle and a positive at the end. So I know they both have to be 2 negatives because 2 negatives multiply together to give me a single positive. Now I have negative 8 and negative 2. Now negative 8 and negative 2 don't get to plug in directly into those parentheses as nicely as it did before, because what's happening now is I'm taking my middle term b and splitting it into those two new terms that I just found, the negative 8 and the negative 2. And you guys said negative 8x plus negative 2x does give me negative 10x. That's all I've done, is I've just taken this middle term and just divided it and separated it into two new terms. Then I'm going to put in imaginary parentheses, and I'm going to find common factor in the first parenthesis, common factor in the second parenthesis. So I can see I can pull out a greatest common factor of 2x, and after pulling out a 2x, I'm left with x. 2x squared divided by 2x is x. Negative 8x divided by 2x is negative 4. Now I'm going to do the exact same thing, pulling out a common factor of negative 2x minus 10, and I can see that is going to be a negative 2. And that leaves me, why did I write 10? It should be 8. I'm thinking, wait a minute, something's not right there. I can still pull out a positive or a negative 2, and that leaves me with negative 2x divided by 2 is x, and 8 divided by negative 2 is a negative 4. So both these parentheses need to be exactly the same, and they are, because now I pull out the common factor, which is x minus 4. And then what's in the second parenthesis, because notice I'm a parenthesis times a parenthesis is my answer, is going to be the leading coefficient out in front, which is 2x minus 2. And if the directions at the top said to factor and solve, I would set both of these sets of parentheses equal to 0. So here x would be 4, and x here would be add 2, divide by 2. X actually would be 1 for that. So pay close attention when you have a is 1 and when a is not 1. Now something that I could have done here, and because I wanted to show you how to work it when a was not 1, let me make that right here. I could have pulled out a common factor. So let's look at D really fast. And I see that I got 3x squared minus 3x minus 6. Before I even started, I can pull out a common factor of 3, and then it leaves you with a really nice, simple factoring problem rather than when a is not 1. And I could have done that with this over here, pulling out a 2 in front. Even if you don't see the common factor to pull out, your answers will come out to be the same. It just saves you a little bit of extra stress if you can pull out that leading coefficient. But if not, you can work it just like what we did here, no problem. That is factoring. Okay, so let's turn the page. And now it says we want to solve. This is where it gets a little tricky because we have different ways in which we can solve. If we are solving, we can look to see if it's a trinomial. We can factor, meaning if it has 3 terms. We can use square roots if it's a binomial, quadratic I should say, and same thing with the trinomial. And I do believe we have all quadratics here, so that's what I'm talking about. So, and I also could use quadratic formula if it can't factor or if it can't use the square root. And remember, quadratic formula is x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. Now, regardless of what I have here, quadratic formula will always work. Okay, that is the one that will always work. So on a and b, these are just like what we did with the factoring, where x is, or our leading coefficient a is 1. Two numbers that multiply give you negative 2, but add to be negative 1. And find your factors, set those equal to 0. So I'll leave a and b alone. Let's look at C. I've got 8x squared minus 3x equals 3x minus 1. Now, if I want to factor, I need to get it equal to 0. If I want to use quadratic formula, I need to get it equal to 0. If I want to use square roots, I need to isolate the square root. Okay? So here, let's first set it equal to 0 and see what we have, and then we can determine which method might be the best. So I've got 8x squared minus 3x. Now let's bring this 3x back over, so I'm going to subtract 3x, and then I'm going to add 1 to both sides to move all of that over. And then simplifying, I get 8x squared minus 6x plus 1 equals 0. So I look at this now, and I see that I have a trinomial, so I'm probably either going to factor or use quadratic formula. My leading coefficient is not 1, so therefore I'm going to have to do two numbers that multiply. What's 8 times 1 is 8, but add to be negative 6. So two numbers that multiply to give you a positive 8, but add to be negative 6. Well, negative 4 and negative 2 multiply to give me a positive 8, and negative 2 plus negative 4 also adds to be, so there it is. So I'm going to rewrite this as 8x squared minus 4x minus 2x plus 1. Putting around my imaginary parentheses, I can pull out a 4x, and I'm left with 2x minus 1. And then over here, I'm going to pull out a positive 1, and I'm left with, or excuse me, let's pull out a negative 1, because I need this parenthesis to match this parenthesis. And right now I'm at a 2x plus 1. I need it to be 2x minus 1. So if I factor out a negative 1, 2x divided by negative 1, or excuse me, negative 2x divided by negative 1 leaves me with a positive 2x, and positive 1 divided by negative 1 leaves me with a negative 1. So I get 2x minus 1 is my common factor, and 4x minus 1 is my second factor. So 2x minus 1 comes out. What's left is 4x minus 1 makes that second parenthesis. And then I set each one of those equal to 0, because remember my directions said to solve. So I add 1 to both sides and divide by 2. So x equals 1/2. Over here I add 1 and divide by 4. So x equals a positive 1/4. Let's look at E. E has 25x squared minus 23 equals 27. Now the reason why I'm picking on E is because I notice it doesn't have a x. It just has x squared. It doesn't have x. So let's see what we got. So let me subtract 27. Let's set it equal to 0 first. That's always a very good place to start. So I get 25x squared minus 50 equals 0, because negative 23 plus negative 27 is negative 50. Now I see that I can factor out a 25. Okay, so I'm getting somewhere. Okay, so I factored out a 25. That looks a little nicer than the 25 and the negative 50. Now, because my 25, and my problem said to solve, those are my directions, because my 25 does not have a variable, I can ignore it, because I'm solving. When I'm solving, I'm looking for x. And if I don't have an x associated with that, it can go away. So now I'm just left with x squared minus 2 equals 0. What can I do with that? It's not a perfect square, because 2 is not a perfect square, so let's use square roots. So let's add 2 to both sides, so I get x squared equals 2. To get rid of a square, I take the square root. And if you remember, anytime that you take a square root, you always get a plus or minus associated with that. So you can leave that as plus or minus square root of 2. Now, depending upon how the answer is written, whether you take that to a decimal or leave it, but that's how you can solve that when there is no middle x available. You can just see, when I say middle x, this is what I'm talking about here on G. There's a middle x, and there's no x here, so I was able to use square roots. And then on G and H, again, you could either try to factor when a is not 1, or this is 1, in which you would have to use your quadratic formula. Okay? All right, number 7. Bluebird in the Angry Game travel path with this equation. What is the bluebird's maximum height? Now remember, anytime you are talking about maximum height, you're talking about a parabola. That's the path that Bluebird would have traveled. So up here, you're looking for your maximum height. And remember to find maximum height in standard form. Looking for vertex, I take opposite of b over 2a, and then to find y, you plug in x back into that original equation. And I'll let you guys work on that, just like I had you working on the quadratic formula here. But remembering that the quadratic formula, opposite of b plus or minus, and then that's just plugging that in into your calculator. And then on the back, we also have Angry Birds, but this time we want to know total distance. We are in intercept form, and so finding our zeros and finding the difference between those two zeros tells us how far it traveled. So for instance, if I have -2 and if I have a +4, so if I find the distance from -2 to 4, that will tell me how far it traveled according to however many units. And then we have this equation for 9. We want to know, does it hit this point or does it hit this point? And understanding, these are my x's, here's my y. And anytime that I have anything written in a coordinate point like that, the first value is x, the second value is y. So you can take your x value, plug it in, and see if that's what you get for the y value. If it does equal, so if 6 opposite of 6 squared minus 3 times 6 plus 3 equals -51, you nailed it. If not, then it didn't hit that, and then you would do the same thing with 2 and -7 to see if that worked. Okay, now I'm with imaginary numbers. And the main thing to remember and understand with complex imaginary numbers is that I can be treated just like a variable. Understanding that it's not a variable because I stands for the square root of -1. And then by squaring I get -1. So those are the two main things that we have to remember with I. So when I have A, and very important to understand that I've got two sets of parentheses, but look at the operation going on between the parentheses. So on A, I've got a plus. C, I've got a minus. E, nothing. So that means multiplication. So A is adding, C is subtracting, and E is multiplying. So we will do those three. You'll be able to do the ones off to the right. So on A, because this is adding and there's nothing that I can do inside the parentheses, the way it's written, I can just ignore the parentheses, pretend like the parentheses aren't even there. So I can take 2 plus 12, and I get 14. 3i plus a -2i leaves me with a positive 1i. And understanding that complex, I leave it with I at the very end. That's just the formal way in which to write it. So I leave it with A, the constant, plus B times I. And there's my I at the end, so I'm in the standard form for complex numbers. Now subtraction, because that's what's in the middle, is a little trickier. I like to say that we leave the front parenthesis exactly as it is. We don't touch it. But we're going to change this to an addition problem by taking everything inside that second parenthesis and changing its sign. So that 17 is going to become -17, and that 7i is going to become -7i. Now I can combine it just exactly like I did above. So 12 plus -17 leaves me with -5, and -3i, and plus a -7i, or -3i minus 7i means the same thing, is a -10i, and I'm finished. E, we can, because I've got two binomials, if you want, you can set up the box for this. So I can put up here -5 and -2i, 3 and 7i. And I think that we did complex numbers before we did the lattice. So how cool it is that we can use the box for this. So that becomes -6i, this becomes -35i, and this becomes -14i squared. So I get -15. -35i minus 6i is what? -41i. And then -14i squared. What did I say I squared was? -1. So that's -14 times -1. I get a positive 14. What's -15 plus 14 is -1 minus 41i is my final answer. There's my negative right there. complex numbers. Okay, writing equations given points. Probably one of the trickier things that we have done this semester. We have to be very careful that we identify what kind of points we have. So here we have x, y, and then a point. So this means that my x value is given on both of these. So can you tell that this is where the x-axis or the points would cross on the x-axis? So it crosses at 3 and it crosses at 7. So 3, 0, and 7, 0. That means I have intercepts. These are my x-intercepts when y is 0. So I'm going to rewrite this in intercept form. So intercept form, let's just remember this really fast. It's been a while. Y equals a times x minus p times x minus q. Each one of my my points here is a p and a q. What I don't have is my a. And I'm going to utilize this. I'm going to call this my p just so you don't get confused. And this is my q. And this is my random point that I'm going to substitute in for x and then my y value. So y is going to be -9. I don't know a. My x is going to be 6. My p is, I take the opposite of it, so it's -3. My x, same x. I go back to this point, my random point. And my q is 7 this time. All right, and so what I'm doing is I'm going to simplify inside the parentheses and understand this a is being multiplied by this parenthesis. It's being multiplied by this parenthesis. So I get -a, or excuse me, that would be a 9. 6 minus 3 is 3, and 6 minus 7 is -1. So 3 times -1 is -3. So I get -3a. I'm just going to write that in the form that we're more common to see it. Divide both sides by -3. So a is 3. So now I get to write my equation. Y equals 3 times x. What was p? And what was q? Not q. That would be 7. And there is my intercept form. Okay? And then you would be able to do the second one just like that, knowing that 4 was my p, 6 was my q, and 1, 8 was my random x and y that I plug in. You'll be solving for a. Okay, back page. Given a vertex. Now, given a vertex in the vertex form with the vertex -3, 7 passing through this point, how are we going to write our equation? So understanding that y equals a times x minus h quantity squared plus k. So I get my, I know my vertex because my vertex is h and k. My y value, this is my x and y, and this is my h and k. So I get 3 equals, and again, I'm solving for a. X is -1. H is -3, so I'm going to take the opposite, becomes +3 squared. K is +7. -3 plus 1 is 2. 2 squared is 4 plus 7. Subtract 7 from both sides. I get -4 equals 4a. A equals -1. So y equals -1, x plus 3, quantity squared, plus 7. Finding my h and k. I want to write a quadratic equation now. Okay, so this is, again, another one just like what we had done. I want to flip back here really fast. And see. Okay. Make sure we covered that, and we did. Alrighty. So now we want to graph the following, and we're going to identify the vertex. Okay, and with quadratics, we can't use slope like we had thought about it, just because it's not they're not lines, they're curves. So quadratics make a parabola, a curve, and curves. So if I went up 1 over 1, it would be very strict and straight, and that's not at all what a parabola is making. So we can pull out our vertex. of 2, 4. Take the opposite of what's inside the parenthesis, and what's outside stays the same. So the vertex is 2, 1, 2, 3, 4. It's positive, so it's going to be going up, and I did not do a very good job of graphing this so that it was proportionate to the graph. I should have moved my x-axis down, and actually I am going to do that. It's just you and me. You don't care. You would rather understand what you're doing than watch your teacher correct herself here. Well, if you're in class with me, you know that I'm doing that all the time. So 2, 1, 2, 3, 4. Here we go. That looks much better. Okay. So now we could set up an XY chart, and understanding that 2, 4 is my vertex. So I'd need a few points below that and a few points above it. What do I mean by that? That's what I mean. And so I could plug in 1 into this equation. So I get 1 minus 2, negative 1 squared is 1. 1 plus 4 is 5. Plug in 0, negative 2. So that's negative 2 squared is 4. 4 plus 4 is 8. So I go 0, 1, 2, 3, 4, 5, 6, 7, 8. And then because it's a reflection, I can go over 2 and I'd have that exact same point. 1, 5, 1, 1, 2, 3, 4, 5. And I would have my graph. And because it's a square, we'll leave it with this, with the points, pulling that in, because you know that you'll get that right using the points. It was another little quick way that we learned, but I think I'm going to leave it like this, being on the video. Okay, we know that that is a positive out in front, so this is going up. If it was a negative, we'd be flipping it down, and that's how I would graph that as well. Okay, now we're going to be simplifying. These are our exponents, and the main thing I want you to remember that with exponents, the rules that we have, if the bases are the same and we're multiplying, we add the exponents. So 3 plus 6, that would be x to the 9th. If we have a power being raised to a power, that means that we multiply, so 6 times 9 is 54. If we have a negative, that means we take the reciprocal, so this would be 2 over 1 to the 4th power, and once you take the reciprocal, once you flip it upside down, then the exponent becomes positive. And then anything inside that parenthesis, you raise it to that exponent. So 2 to the 4th is 16, 1 to the 4th is 1, 16 divided by 1 is just 16. Now you have to be careful, because if you go down here to I'm saying if there's a negative exponent, you take the reciprocal. Well, you don't flip the whole thing. You only take the reciprocal of whatever's being raised to that negative exponent. So negative 3 stays put, and that negative isn't a negative exponent. That just means that's a negative 3 versus a positive 3. My x and y here both have positive exponents. They're staying put. The 9, no negative exponent. X cubed, no negative exponent. But the y to the negative 4 is. It's in the denominator, so I'm moving that up to the numerator. All right, so now I have, what's negative 3 over 9? That leaves me, don't forget, I have a negative out there. I can reduce that down to 1/3, okay? So 1/3 reduces the 3/9. I have x over x cubed. This is a 1. So I have x to the 1 minus 3, which is x to the negative 2. That negative means it belongs in the denominator, and hopefully that makes sense, that you see that you have a bigger power in the denominator than you have in the numerator, so that result better end up in the denominator. And then I have y to the 1st times y to the 4th, which is y to the 5th. Okay, that was a really good one as far as our exponents to go. And always remember that if you have anything raised to the 0 power, it is always 1. Okay? All right, so that's working with our exponents. Flipping to the back page. Here we are solving again, and this is where we're going to be solving. Again, we have our different ways in which we can solve. We can factor, we can use quadratic formula, we can use square roots when it comes to a quadratic. And if I only have just an x squared and then a constant, don't overthink that. That's just a simple square root. By taking the square root of both sides, you can get rid of the square, leaves you with just x, and the square root of 64 is again plus or minus 8. If you have a constant out in front, you would divide by 3 first, get an answer, and then take the square root. If you have a square surrounding a binomial, you want to isolate that binomial first. So here I would divide by 4, and then I'm left with x plus 2 quantity squared equals 100. Now, we're not limited to just an x that I can take the square root of, or just a number. I can take the square root of an entire binomial like that, as long as what I do to the left, I do to the right. Again, that square root gets rid of that square, and I'm left with just x plus 2. What's the square root of 100? Plus or minus, don't forget that plus or minus, 10, which means I'm going to have x plus 2 equals a positive 10, and then an x plus 2 equals a negative 10. I get 2 problems out of this, 2 for the price of 1. So I'm going to subtract 2, so x equals 8. I'm going to subtract 2, x equals negative 12. I could have 2 possible solutions. Here on G, I'm going to add 2 to both sides. Again, I'm getting my square. Looks like I'm going to be using square roots. Divide by 5. X squared equals 3, so x equals the plus or minus square root of 3. Remember, by taking that square root. Okay? Then our last, something that we just covered, we want to determine whether the polynomial is a function or not. And what we're doing is we're looking at the exponent must be positive and a rational number, a whole number, I should say, an integer, a whole number, okay? So just by looking at this, I can see that on number 3, no go, and number 4, no go, because that would be x to the 1/2. Can't have that as a fraction, and we have to have a constant and not a variable as a exponent. Direct substitution, we're going to take this value 2 and substitute it every time that I see an x and get a value. That shouldn't be too horrible, because you can put that directly into your calculator. So 2 times 2 cubed plus 2 squared minus 2 times 2 plus 1, and then type that directly in. Then it says to perform the operation, and this is very similar to our complex numbers that we had, except for the fact instead of i's, we've actually got variables with exponents. So I'm going to change this to a cube right here. So I'm going to this is a plus, this one's a minus, and these are multiplying. So remember, on the addition, we add only our x cubes, only add the coefficients. So this would be 1x cubed, then 6x squared minus 8x squared is a negative 2x squared. Negative 5x plus 10x is a positive 5x. And 5 minus 7 is negative 2. You would do the same thing with the subtraction, but just like with the complex numbers, I'm going to change the subtraction to addition. That's going to become a negative. That's going to become a positive. That will become a negative, and that will become a positive. And then again, I combine my like terms according to adding the coefficients and keeping the exponents. And this is where we used our box. So I'd have 2x here and a y here. Who cares that there's more than one variable? You would treat it just like you would a number. So 4x squared, 2xy, 2xy, and y squared. So I'm left with 4x squared plus 4y, that would be an x, 4xy minus y squared is what I would end up with here. And that was a minus up there. Well, if that was a minus, then this is totally incorrect, because I wouldn't have any xy's left. So I'm left with 4x squared minus y squared, my bad. Sorry about that. Okay, and then again, you would use the box here. All right, good luck on your final exam.